A very warm welcome to all my viewers to your favorite SDM classes. It is only your love and support that has helped and encouraged my comeback and add more videos to my channel. I thank all of you and request you all to please like, share and subscribe my channel so that I can bring up more and more tricks for various other topics of biology and chemistry. Dear friends, today I have come up with another video on trick to find out group number and period number of any element in the periodic table. And this video will be helpful if you are a student of class 9, 10th, 11th or 12th, as well as even beneficial if you are preparing for NEET examination or any other competitive examination. So let's begin with the topic, that is to find out period and group number of any element. Now it basically consists of 3 steps, and let us see stepwise how can we go. So step 1 is to write the electronic configuration of the element for which the period number and the group number has been asked. And please remember that we have to write this electronic configuration in KLMN format. I hope everybody is aware of the KLMN concept. We study it in the 9th class itself. And first step comprises of writing the electronic configuration in KLMN concept. Okay, one more important thing to note over here is that you will be able to write the correct electronic configuration in KLMN format only if you know the atomic number of that particular element, right? Because we all know that the atomic number of any element is equals to the number of electrons which are present in that element, right? Okay, then coming over to the second step. Step 2 will help you find out the period number. Now once you have written the electronic configuration in KLMN concept, then period number is equals to the number of shells filled by the electrons. Let's take up one example to understand this. For example, we want to know the period number of sodium, Na, and we know that its atomic number is 11, right? So according to 11 means there are 11 electrons in a sodium atom. So if I write its electronic configuration in KLMN format, I get 2, 8, 1. So how will I judge the period number according to this? The period number of sodium will be KLM, that means 1, 2 and 3. Since 3 shells are filled by the electrons that are present in sodium, so its period number will be 3. It is as simple as that. Let's take up another example. If I give you to find out the period number of calcium. Calcium, we know the atomic number is 20. Now write down the electronic configuration in KLMN format. We get 2, 8, 8, 2. So how many shells are filled? 4. Automatically from this we get that the period number is 4. Let's check out this in the periodic table. If we see in the periodic table, as I told you, for sodium it's falling in the 3rd period, and as I told you for calcium it's falling in the 4th period, right? So that means our results are correct. So this is the way how we find out the period number. Now quickly let's move on to the group number. So our step 3 is group number. So to find out the group number, there are few sub-steps in step number 3, and you have to remember all those substeps, and I will explain you each substep with the help of an example. Let's see the first one. In the first case, if the number of valence electrons in that particular atom is 1 or 2, then the group number will also be 1 or 2 respectively, right? That means if any atom is having valence electron 1, so group number will be 1. If the valence electrons are 2 in that atom, then group number will be 2. Simple example you can take up over here. The same example of sodium and magnesium. You can try out for your own self. See, sodium is 281 and magnesium is 282. You can see in sodium valence electron 1, so this will fall in group number 1, and magnesium, since it is 282, last valence electron number is 2, so it will fall in group number 2. Let's check out in the periodic table. So here we have the group number. As you can see, sodium is falling in group number 1 and magnesium falling in group number 2. So this is the rule for the first substep. If the valence electrons are 1 or 2, then the group number will be 1 or 2 respectively. Second, if the valence electrons are from 3 to 8, then the group number can be calculated by 10 plus the number of valence electron. Let's take an example again. Chlorine 17, and let's do for aluminium 13. So chlorine will be 287, right? And aluminium will be 283. Now chlorine is last valence electron is 7. So I said 10 plus the valence electron, that will be 10 plus 7. That means chlorine falls in group number 17. For aluminium, last shell is having valence electron 3. So 10 plus 3 is 13. Let's check in the periodic table for chlorine and aluminium. We can see over here, chlorine is falling in group number 17 and aluminium is falling in group number 13. So our results are correct according to this formula. Then let's go to the third substep. So now for elements 19 to 57, that means those elements which have atomic number from 19 to 57, then in this case the group number is equals to the number of valence electrons. Let's take up example of iron. Iron is 26, and let's take up bromine, which is 35. So if we look to the electronic configuration of iron, it is 2, 8, 8, 8, and electronic configuration of bromine is 2, 8, 8, 17. Okay, so I said over here the group number will be equal to the valence electron, and we know what is valence electron, the number of electrons present in the last shell. So for iron it is 8, so here the group number will be 8, and for bromine, since it is 17, group number will be 17. So let's check out the results in the periodic table. For iron, it's falling in group number 8, and bromine is falling in group number 17. Right? So always remember, for elements from 19 to 57, the group number will always be equal to its valence electron. Okay, now I would like to tell you over here that I have written the electronic configuration in which format. You have to follow the same format. 2, 8, 8, 18, 18, 32, 32. Right? We have to fill up the electrons in this concept, in this format. Only then you will be able to follow up these sub-steps to find out the group number. Let's go on to the fourth sub-step. Fourth sub-steps is for lanthanoids and actinoids. So my dear friends, if the elements are ranging from atomic number 58 to 71, then the group number will be 6. And we all know that these are characterized as lanthanoids. And if the atomic number of element is 90 to 103, then the group number will be automatically 7. These are known as actinoids. This you can simply learn, right? So if the element is having atomic number from 58 to 71, automatically group number 6. 90 to 103, then group number automatically 7. Last is the rest of the elements. What are the rest of the elements? That is from 71 to 90. This gap, 71 to 90, and 104 till 118, since only 118 elements have been discovered till now. Okay, so for rest of the elements, the group number will be equals to valence electron minus 14. Valence electrons, whatever is the number of valence electron, deduct 14 from that and you'll get the group number. Let's check out with the help of an example. Let's take up gold. Gold is 79, and let's take up this is known as Seaborgium element, whose atomic number is 106. Okay, so for gold, if I write the electronic configuration, that means the number of electrons should come up to 79. It will be 2, 8, 8, 18, 18, 25. Okay, since here we were supposed to fill 32 electrons, but only 25 electrons are left for gold in the last shell, so its valence electron will be 25. Now I told you the rule is, to find out group number, the rule is valence electron minus 14. What is the number of valence electron? 25. And if we deduct 14 from 25, we get 11. That means gold falls in group number 11. Let's check out. Where is group number 11? And yes, we can see gold falls in group number 11. Let's check out for the next element which I have written here, Seaborgium, and I'll write its electronic configuration: 288, 18, 18, 32, and the last shell will contain 20. Although it can accommodate 32, but we are left only with 20 electrons, 20 electrons. So the last valence electron number will be 20. So according to the rule, I will deduct 14 from 20 and that gives us 6. So that means our group number will be 6. Let's check out for this. Element number 106, Seaborgium, and according to our result, falling into group number 6. So these were the rules to find out the period number and group number of any element. And believe me, my dear friends, if you learn these simple rules, you will never make a mistake of finding the period number and group number of any element asked to you in any of the question. So I hope you liked my video. Please comment about the video and like, share and subscribe for my channel. Thank you so much. I will be coming up soon with some more interesting tricks on other topics. Thank you so much.